Okay, so as far as water chiller anatomy goes, well, you really take the same principle of a reverse cycle or heat pump air conditioner and just apply it to water. Instead of having an indoor coil to exchange heat with air, you have a coil inside a drum or a tube which exchanges heat or removes heat from water. In this case it's removing heat because it can run as a heat pump and heat the water going through it, like for a pool, which is what it was designed for. But we ended up using this one as a chiller, and all it does is absorb heat from water and exchange it out through the coil. So it's the same principle. You've got high pressure refrigerant coming out of the compressor, going to here, going through the condenser coil, exchanging all the heat. Heat gets blown off by the air from the fan, or drawn out, I think it gets drawn out through the top. Liquid refrigerant, which is condensed through the coil, comes through here, metered by the thermal expansion valve, which is regulated by suction line temperature and can dump liquid to suction line if needed. Goes through here, through this coil and into the chiller drum, where it starts to evaporate, it starts to evaporate here as it comes through the TXV. As it's evaporating, it's absorbing heat from water in here, and then returns to the system as a vapor back down through here. Any excess liquid gets trapped and evaporated inside that canister, and you get refrigerant vapor and oil vapor coming back to the compressor. So it's the exact same principle as any other air conditioner, reverse cycle or not, but you just replace the indoor unit with a refrigerant to water heat exchanger. That's it. The electronics vary a little bit, but apart from the electronics and the fact that you're exchanging with water, not air, they're all essentially the same. So for those of you who were asking what the difference is, that's pretty much it. You're just exchanging with water, not air. Okay, I've got the last one coming apart now. I recovered it this morning. That's the little pump unit that I built. I'm not going to go into detail on that one. It's bad enough knowing that I've got it. I don't know what's more illegal, venting it to atmosphere or doing the right thing and recovering it to cylinders. I mean, I don't have 2.5 to 3 years to do a full apprenticeship and get into the industry just to be able to handle a bit of refrigerant. It's not like the United States where you can get your ticket pretty much online. Over here, you got to enroll in an apprenticeship, you got to get an apprenticeship with a refrigeration company and do all that stuff. Yeah, it takes about a couple of years and a lot of money, good few $1,000s. So I'm happy in fitting and turning. I'll stick to this as a hobby, thanks. But yeah, you can see the refrigerant tubes going in and out of the internal exchanger. I'll try and get this open. I'll probably unscrew one of these plugs and just give you a quick look inside. I don't want to disturb the end gasket because I know that's sealed. But yeah, it's a marine heat exchanger. I was talking to a friend at work and he suggested marine air conditioning will use this, or big refrigeration from the UK suggested the same sort of thing for an onboard fridge or something like that. When you've got a big abundance of water, instead of having a air-cooled fan coil assembly, you just install these things and circulate water through them. It's a lot easier. You don't have fans and other stuff running, it's just a pump. So that's that. Bit of tubing to keep. There's some nice copper in there for odd jobs. Again, pressure sensors and things like that. The TX valve sensing bulb coming straight off the accumulator. Single phase fan, it's very old and degraded. Won't be keeping any of that. I'll keep the timer and the plug base there, octal socket. The solid state time delay relay there. There's some good stuff. Anyway, I'll keep stripping it down. And that's the other one. I'll keep all that on the base. It's all one unit. Okay, I've got the fan out. Decent sized cowling on it. It's about 1 metre by 800 millimetres. And as you can see, the coil looks okay from a distance, but when you get up close, it's almost gone. That's why it wasn't working properly. It's dead. Anyway, I'll get the sawzall out and cut all that off and get the compressor out, and that should do it. The screw still in that one. Okay, before I cut this up, I just thought I'd ask, why would there be a fusible valve on the suction side? I mean, I can understand the high pressure side, but the suction side's generally cold and sweaty regardless of what mode it's in. I'd hardly expect it to melt a lead plug. And that's all that is, there's a little lead plug in there which blows out, melts and blows out if the systems have something seriously wrong with it. I mean, the only time that'd blow out is in the event of a structural fire. If this unit was involved in a fire, that'd probably be the first thing to go. Yeah, interesting. I've seen them on liquid accumulators, like liquid receivers from the condenser, but that's to be expected. It will get high temperature liquid or vapour. Vapour if it's not working properly, but why there's a blowout plug on the suction line's beyond me. Anyway, that's about the end of this one. I'll do a few more final bits and pieces, but I'll upload this for now. Thanks for watching. And that's a Copeland compressor as well, a decent size.